Alright, Chapter 2, Lesson 8, Constant Rate of Change. That's our notes. So give you a second to get caught up. So our central question for today: how are proportional relationships helpful to determine constant rate of change? So that's our goal. So what it means, constant rate of change, is exactly what it sounds like. It's a rate of change that's the same between one or more quantities. So we get into our examples. So we want to make yourself a table. Call it hours and miles for the first one. We go 1, 2, 3, 4, 5, 60, 120, 180, 240, and 300 is our hours. And then if you have a different color you can write with, it'll probably be beneficial. So you can tell the difference between what you started with and what you finished with. So what we're looking for is what is our rate? How is it changing? So we want to know what's our change in miles compared to our change in hours. So if we look at change in miles, we just pick any two, and we say, how are we getting from 60 to 120? Well, that's an increase of 60. And then we're looking to see if does that pattern continue. So from 120 to 180 is also plus 60. From 180 to 240 is also plus 60. And wouldn't you know it, from 240 to 300 it's plus 60. So our change in miles is always 60. And then we compare that to what's our time changing by. So from 1 to 2 it's plus 1. From 2 to 3 plus 1. 4 to, I think I missed one. 3 to 4 plus 1. And from 4 to 5 plus 1. So our change in hours is increasing by 1. So we have a constant rate of change, and it's 60 miles every 1 hour, 60 miles per hour. So this would be a linear relationship. Okay, that's example 1. Oh, I'm supposed to write this down in words. Okay, so the constant rate of change is 60 miles per hour. Okay, that's example 1. That's all we're doing. We're going to take a table and we're going to look for the pattern. So same thing here. So we have a table about cars being washed. And we want to know what is the change in dollars, change in money, compared to the number of cars. So the change in number of cars. So we do the same thing. We just see what we're adding or subtracting by. So in this case, from 15 to 45 is plus 30. 45 to 75 plus 30. And it's the same all the way down. And then over on the other side, our number of cars is also changing, but this is changing by 2 every time. Plus 2, plus 2. So then our rate would be it's $30 for every 2 cars, and then we can simplify that to $15 per car. So the constant rate of change is $15 per car. This is also a linear relationship. But spoilers, this is not proportional. No, wait, it is proportional. Never mind, ignore me. Proportional and linear with a constant rate of change. $15 a car. Okay, so then we go to the back. So that's with tables, and that's nice. Our second example, we're going to look at how we can find the same thing with graphs. So we make ourselves a graph, and we say y is going to represent distance in miles, and x is representing time in hours. So similar to number one, I think it's the same as number one, is miles per hour. And hopefully, most of the examples you get in 6th grade will give you points to use. So if you're having trouble seeing where my line is going, we should have points at 0, 0, and 160, and 2, 120, and one last point at 3, 180. And if we flip back to the other side, you can see that the points we plotted are the same as the ones that came from our table in example 1. So we should already know the answer is going to be 60, but we can see how we can get that on our graph. Okay. So we're still looking for change in miles. Oh, this is multicolored. So we're going to say distance in miles is green. Divided by, and then our time is going back to hours. So change in hours. So all we need to do is we pick any 2 points. So let's say we pick 0, 0, and 160. So that's a nice easy one. And we say, how much does it go up by compared to how much does it go over by? Okay. Or we can also say, literally, what is the difference between them? Like our miles, we're saying, what's the difference between 60 and 0? Which is 60. And then at the same time, our time, what's the difference between 1 and 0? Okay, and this should be equal to anywhere else on the line. So let's say we went this way and then over. Okay, so this time we're going from 60 to 120. So what's the difference between 120 and 60? And then our time changed and went from 1 hour to 2 hours. So what is 2 minus 1? And that's still the same answer. It'll be the same no matter which 2 points you pick on the line. This will always be 60 over, there's a lot of color changing going on here, over 1. So our answer is still the constant rate of change is 60 miles per hour. So all we do is we pick a couple points on the line, and we say, what's the difference in y compared to what's the difference in x? And since we know it's a line, we can see it. We don't actually have to check every single point, because we already know it has a constant rate of change, because it's a line. So we just need to know what is the actual rate. What are the numbers that go with it? Okay. One last example, and then we're done. So it's nice and easy today. So example 4, we're talking about allowance. So that's in dollars compared to our time in weeks. So we want to know how much allowance do we get per week. And so our points here we have, we need some to get you going. We have 0, 0. Oh no, what happened to my row? Hold on. Oh, this is no good. Because all these got moved over a little bit. So this 1 should be right here, and then 2, 3, 4, 5, 6, 7, 8, and 9. So that's my bad. Each of these squares should be 1. The picture got away from me. Oh well. So our next point is 1 week, $10, and then 220. So basically we're just counting by tens, and then it's just up 1 over 1. Okay. So we still write a rate the same way. So we want change in money, or change in allowance. We'll put money here, so it's shorter. Compared to change in weeks, change in time. Oof, okay, I did not do that well. Weeks. So all we need to do is we pick any 2 points. So let's say we pick this point and this point. Why not? So you say, how much does this go up by? How much does this go over by? So it went from 20 up to 40. So the difference would be, what is 40 minus 20? And then over that same distance, what did the time change by? So it went from 2 to 4. So the difference would be, what is 4 minus 2? Okay. And then we just do that math, which hopefully is not too hard. 40 minus 20 is 20. 4 minus 2 is 2. And then we can just simplify that. Okay, so equals, that should be, uh-oh, get my colors confused. Equals 20 over 2 simplifies to 10 over 1. So our constant rate of change is $10 per week. Okay, so that's it. Constant rate of change, which should get an abbreviation, right? So we don't have to write constant rate of change. We should call that the CROC, the croc. We learned about the croc. Go back to class tomorrow and tell Miss Geyer that you're excited to talk about the croc. Okay, she won't know what you're talking about until someone gives away the secret. Okay, so be subtle about it. Definitely mention the croc. Okay? Okay. Go on the website and find something and write some notes about it. Put it in your summary. Okay. Good night.